Welcome to the Chapter 7 test skill tutorial. So here's problem number 1 that you'll see in the test. And you've seen the test already. These are the same problems. Different numbers, but it's the exact same kind of problem that you'll see again on Monday. So this is finding the intersection of two lines using algebra. And so here's a problem like what you'll see in the test. Y equals a half x minus 1, then y equals another line, negative 4th x plus 5. So before we start the algebra work, realize there's two techniques you can use here. There is fraction busters and there is not fraction busters. But before we do either one, let's go to an actual graph and see where these lines cross in the first place. So there's a useful website. It's called fooplot. Go to fooplot.com and it lets you graph any functions for free. You can graph up to 5 equations on one graph. So let's enter a half x minus 1 for the red equation. And notice that I put the slope in parentheses. The reason for this, without the parentheses, some computers will interpret this as you want to do 1 divided by 2 and divided by x. You don't want that. You want a half to be the slope that gets multiplied to x. So make sure you put the parentheses in there just to be on the safe side. All right, second equation, y equals negative a 4th x plus 5. So I'll enter this as a blue equation. Negative parentheses a 4th x, then plus 5. And notice on the graph, when I hit plot, I don't see the blue line. Well, there's a reason for that. Look at the y-intercept. The y-intercept's a height of 5, and my graph only goes up to 2 point something. So with fooplot, there's a pan tool. You can just click and drag around. So let's drag up to a height of 5 for the y-intercept. And find, there it is up there. So there's the blue line going through a y-intercept of 5. And we're looking for the intersection point between these two lines. It looks like they're crossing somewhere off to the right, so I need to drag over till I can find the point of intersection. So here it is. It looks like x is 8 and y is 3. And down below, there's an intersection tool. Click it once, and then click anywhere nearby the point of intersection, and fooplot will find the point of intersection for you. So indeed, we were right. The x coordinate is 8, and the y coordinate is 3. So let's go back to the algebra and see if we can find the same thing, that x is 8 and y is 3 for these two lines. We're going to start off with the fraction busters technique. And since this is a system, we still have to choose which kind of system of equations method we want to solve by. That's an elimination method, or equal values, or substitution. In this problem, since we have y equals for both equations, the equal values method is going to be the easiest. So let's use the equal values method and set one equation equal to the other. We have half x minus 1. Set that equal to the other equation, negative a 4th x plus 5. And from here, we got to do the fraction busters technique. So the first step of the fraction busters is you need to find what the LCD is of the entire problem. So for us, there are two fractions, a half and a 4th. So find a number that 2 and 4 can both go into, and find the smallest number for which that's true. In our case, the LCD is 4 because 2 goes into 4, and 4 also goes into itself. So 4 is our LCD. Now with fraction busters, once you find the LCD, multiply the top of every term by the LCD. So 4 gets multiplied to the first term, 4 gets multiplied to the second term, 4 gets multiplied to the third term, and same thing at the end. 4 gets multiplied to the 5. And now, here's the idea. 4 is a number that 2 goes into, and so does 4. So this is going to cancel out all the fractions in one step. 2 goes into 4 2 times. And over here, 4 goes into 4 completely and cancels out. There are no more fractions left over. So left over is we have 2 times 1x, which is 2x. We have negative 1 times 4 is negative 4. On the other side of the equation, we have the 4's canceled out completely, leaving us with negative 1x. And negative 1x can be written as negative x. Over here we have 5 times 4 is 20. Done. In one step of fraction busters, since we chose the right LCD, every number that was a denominator got canceled out into the LCD. So from here, it's a regular problem. Let's move the x's to the left-hand side by adding x to both sides. These guys cancel out. 2x plus x is 3x. Same thing with the numbers. Let's move the negative 4 to the right-hand side by adding 4 to both sides of the equation. Those guys cancel out. 20 plus 4 equals 24. And then for our final step, we need to divide both sides by 3. So the 3's cancel out. We've got x is equal to 24 divided by 3, and 24 divided by 3 is 8. That's the same thing that we found online. If you go back to the graph, rewind the video, the two lines crossed at an x location of 8. To find the y value, let's make some space off to the side. Let's plug in this 8 for the x value into either equation. It doesn't matter which one you use whichever one seems to be the easiest. I think the half looks easiest to plug into, so I'll plug in there. So it's y equals 1/2, and then times, let's put the value of x in place of it. So a half times a value of 8 for x, and then still minus 1. And let's work this out. A half of 8 is 4, and then 4 minus 1 is 3, so our y value is 3. And that matches the same thing that we saw on the graph. So the two lines cross at an x location of 8 and a y location of 3. So there's our final answer by the fraction busters technique. Now let's look at how to do this problem without using fraction busters. So here's the non-fraction busters way. Now, you might even find this easier. If you're okay with fractions, honestly, you'll find this method perhaps even easier than fraction busters. So let's set up the equal values method, same way we did before. So one equation equals the other one. Negative a fourth x plus 5. Now with this technique, you just solve as normal from the very first part. So we need to move the numbers to the right-hand side. So let's add 1 to both sides of the equation. These guys cancel out. 5 plus 1 is 6. And then in the same step, let's move the variables to the left-hand side by adding 1/4 x to both sides. Add 1/4 x to this side as well. Great, these guys cancel out. So now we got to figure out what's a half x plus a fourth x. Well, since we've already been through the fraction tutorials, that's not so bad. We've got a half x plus a fourth x, and for now there's no reason to write the x's in there. A half plus a fourth will be the same thing as a half x plus a fourth x. So let's do a half x plus a fourth x, and from the fraction video, we know we need an LCD of 4, so we need to multiply this fraction by 2 to get an LCD. Now we've got 1 times 2 is 2, 2 times 2 is 4 on the denominator, and the second fraction can stay in terms of fourths as it was already. 2 plus 1 is 3, and it's all over a common denominator of 4. So in our scratch work, we found out that a half plus a fourth is 3/4, so a half x plus 1/4 x is 3/4 x. We'll put that over here. All right, final step would be the same thing you'd be doing with regular non-fractions, just divide both sides. In this case, we need to divide both sides by 3/4. And what you do to one side, you must do to the other side. So divide by 3/4. 3/4 divided by 3/4 cancels out. So we're done. We've got x equals, now 6 divided by 3/4. Remember from the first video on dividing fractions that to divide by a fraction is the same as multiplying by its reciprocal. So instead of dividing by 3/4, we're going to multiply by 4/3. We'll make 6 into a fraction, and from here we choose either method 1 or method 2, either reduce first or second. I'm going to reduce first. 3 can cancel into 6 twice, and left over is 6 equals 2 times 4, which is 8. So we found the same answers we did in the first with using fraction busters in the first technique. So to find y, you'd plug in 8 back into either equation. We already did that before. We're going to get 3 for the y value, and we're done. So here's one more problem for you to try. I'm not going to work it out, but try this on your own. Enter the graphs into fooplot and see if you get the same solution that fooplot shows you to where the lines cross. All right, next video, we're going to do a more complicated example that has messier numbers, but it'll be the same kind of thing. So I'll see you next tutorial.